Professor Peldon. This is Algebra 2, Chapter 5, Section 4, Solving Radical Equations and Inequalities. Inequalities will be on page 4. So, radical equations, so the first part here, these ones all have a singular x to a singular power. The first problem, the x is to 1/2 power, and the second problem, x is to the 1/3 power. So since you have a singular x, you can use the order of operations here, using the isolation method. You do not need to use factoring. So order of operations is the grouping symbols, followed by exponents and radicals. Logarithms are in there too, but we're going to leave those out for now. Multiplication and division, and addition and subtraction. Okay, obviously you go forward to simplify, and you go backwards to solve. The first priority is simplify. The second priority is solving. Simplify involves one side of the equation, i.e. expressions. Solving involves two sides of the equation, properties of equality. And there's the second thing that you do, so it involves both sides of the equation. Okay. Let's give it an attempt at a few of these. Okay, so add subtract step. I'm going to minus 3 to both sides. So I get 2 root x plus 1 plus 0 equals 4. Multiply divide step. I will divide by 2, because that is a multiplier right there. So root x plus 1 equals 2. Remember, this is a square root, exponents and radicals. So x plus 1 to the second power equals 2 to the second power. So if I simplify, I get x plus 1 equals 4. Remember, the square root or any root counts as a grouping symbol. So when you drop the radical, here is a parentheses inside. So grouping symbol is the last step, minus 1, minus 1. So x equals 3 is the solution. If you plug 3 back in, you'll get the square root of 4, which is 2, times 2 is 4, plus 3 is 7. So that actually works. Okay, next one. Add subtract step. Add 1. Multiply divide step. So we have the third root of 2x minus 9 equals 8. That's a multiply right there, so we'll divide by 4. So we have the third root of 2x minus 9 equals 2. So now we're at the exponent radical step. So the third root, the inverse operation is the third power. Oops. Let's erase that. It should be a 2. So that's 2 to the third power. So 2x minus 9, which is in parentheses, equals 8. So the grouping symbol twice, so we'll add 9. So 2x equals 17. Grouping symbol again, divide by 2. So x is 17 halves. Okay, you can plug that back in for yourself. If you plug that in, 17 halves times 2 is 17. 17 minus 9. Let's see, that's going to give you 8. Third root of 8 is 2. Times 4 is 8 minus 1 is 7, so that works also. Pause the video, try the student problems for yourself. Okay, let's try the student problems. Add subtract step. Whoops, didn't work there. Add subtract step. So 2 roots of x plus 25 equals 4. Multiply divide step. Divide by 2, because that's multiply. So root x plus 25 equals 2. Exponents and radical. X plus 25 is a second root, so we want the second power. So x plus 25 isn't a grouping symbol. So grouping symbol minus 25. So x equals negative 21. You can plug that back in for yourself to verify that actually works. Because negative 21 plus 25 is 4. Square root of 4 is 2. Times 2 is 4. Minus 4 is 0. Okay. Next one. Add subtract step. minus 6, 2 third roots of x minus 3 equals 4, multiply, divide step, divide by 2, divide by 2, third roots of x minus 3 equals 2, exponents and radical, so to cancel a third root, we need a third power, which is 2 to the third on the other side. So that gives us x minus 3 equals 8, and grouping symbol, add 3, so x equals 11. Okay. Keep in mind you can rewrite the radical step also, because this can also become x minus 3 to the 1/3. So when you do 3 to both third power to both sides, what's essentially happening is you have a power to a power rule, so you have x minus 3 to the 3/3, or x minus 3 to the 1, or simply just x minus 3, hence why this happens. Okay? And you can use that for any of the roots in this lesson. You can write them either way you'd like, as an exponent or as a radical notation. That is the end of part 1.